The last example is a little bit easier than the previous one. This is coming out of 7.3. A plane is flying with an airspeed of 170 miles per hour and a heading of 52.5 degrees from due north. Its true course, however, is at 64.1 degrees from due north. If the wind current are constant 40 miles per hour, what are the possibilities for the ground speed of the plane? So this is the picture that we have. I start with the fact that the heading is 52.5 degrees from due north. So this is this 52.5 degrees. And it's 170 miles per hour. I also know that the actual course is 64 degrees, 64.1. But I have no idea what this is, so I'll label it as X. I also know that the wind current is at 40 miles per hour. So what that means is this 40 miles per hour, it can be either running against it or helping this guy out. So I can either have the 40 here or I can have the 40 here. Both will make a picture that makes sense. I'll draw it in green. So what I will end up with, two answers. This is my ambiguous law of signs. I know this is 40. I know this is 40 miles per hour. But I will have two answers. One that I'll call X, and the other one, which is in green, I'll call X prime. Setting this up is fairly simple. I do need to find the discrepancy that the wind causes on the degrees. So you find the difference between 64.1 and 52.5 degrees. It does come out to be 11.6. The picture is clear enough that I do not need to redraw this. So you do know the beginning, sine of 11.6 degrees. The sine that's opposite of that particular angle is 40. We also know that I have 170. So this is on the bottom, 170. And this is the angle that I will label as alpha. So I need to find what that alpha is. Now, of course, this would be alpha and this would be alpha prime, because there will be two answers to my problem. So if I'll have sine of 11.6 degrees, sorry, we already have that. So sine of alpha will then be 170 times sine of 11.6 degrees divided by 40. You put this in a calculator, you will have 0.8546. You put this in the calculator, the calculator will spit out an answer. One of the answers it'll give you is 58.7 degrees. So that's this acute angle. So that's what my calculator gave out. 58.7 degrees. The other one is the obtuse. So that's the reference of 58.7 in quadrant number 2. So 180 minus 58.7, that gives you the 121.7. That's my alpha labeled right here with obtuse. This will give me opportunity to find theta or theta prime. I'll move this out of the way. I already know that one of the angles is 11.6. If I found one of the angles to be 121.7, to get the other angle, which I'll label as theta, I can get, I'll take 180 minus 11.6 minus 121.7. I'm gonna get 47.1 degrees. On the other side, I'll have this theta prime, which is the other triangle. So one of the angles is 11.6, the other angle is 58.7. My third one has to be 180 minus 11.6 minus 58.7. It will come out as 109.7 degrees. I have all the information I need. What else I need is to find the actual x. So this gives me two angles to work with. I have two more laws of sines that I can get out from here. So sine of 11.6 degrees divided by 40 will then be sine of 47.1 degrees divided by, so this is my 47 is my theta, so that's my x. Or similarly, I'll have this same proportion, but now I have my other angle, so sine of 109.7 degrees, that's my theta prime, opposite of this whole piece, so that's my x prime. So the x will then be 40 times sine of 47.1 degrees divided by sine of 11.6 degrees, and then x prime will be 40 times sine of 109.7 degrees divided by sine of 11.6 degrees. This is calculations. X will come out to approximately 146 miles per hour, and x prime will come out to 187 miles per hour. So if the wind is helping the plane, it'll go faster. If the wind is against the plane, it'll go slower. That's the end of that.